directional couplers. In microwave, directional coupler is one of the power dividing component. Directional couplers are reciprocal, lossless, matched 4-port network with a facility to have portions of the forward and reverse waves on a line at two of its ports separately. So the directional coupler has been given like this, two of its ports separately. And here we are having primary, and here it is the waveguide end, it is the secondary one. And directional couplers is also called a symmetric coupler and quadrature type hybrid, as it is having 4 ports. The directional coupler consists of a primary waveguide 1 2 and a secondary waveguide 3 4, like this. When all ports are terminated in their characteristic impedance, there is free transmission of power without reflection between port 1 and port 2, and there is no transmission of power between port 1 and port 3. See, here it is. So when input is given on primary port 1, there is no reflection and there is no phase change observed in port 2, but port 3 is fully ideal, so it is not connected with the port 1. So here we are having matched termination. At port 4 we are having the same power with a change in phase. So this is what given over here. And the degree of coupling between port 1 and port 4 and between port 2 and port 3 depends on the structure of the coupler. This is one of the important point. And the operation of directional coupler is calculated based on the coupling factor and directivity. The coupling factor is a measurement of ratio of power levels in the primary and secondary lines. And so the coupling factor has been given as primary and secondary line. And so coupling factor is how the port 1 is coupled to port 4. That's what we have to see with the coupling factor. Because port 2 is directly connected, and so there is no need to find it. But when we see with the port 4, which is having a phase change, we have to check with coupling factor. So coupling factor in dB is equal to 10 log base 10 P1 by P4. And the another one parameter is directivity. The directivity is measure of how well the forward traveling wave in the primary waveguide coupler coupled only to a specific port of the secondary waveguide. So we have to check with port 3 and port 4 for directivity. So 10 log P4 by P3. P3 is perfectly matched, and so we have to find only the power which is reflected out at the P4. Okay, so as ideal directional coupler will have infinite directivity. We'll have 30 to 35 dB of directivity in directional couplers. The applications are power monitor and reflectometer.